Okay, so in our previous session, we talked about the basic programming of CAP, and now we will just try to talk about things like sets and sorted lists and like how we do those things in CAP. So let's say we have a sort list which we can write as we have set. So previously, we have talked about lists and matrices. So let's say we have a set which contains a list which has elements 5, 2, 8, 9, and say -3. We call this a set which has this list as an element. Now we use the function addSet, which will do L and 4. Okay, and then let's call L. That would add what? That would add 4 into the list which is inside the set. Okay, then we can do union, and that would be union of L with the list which is from 3 to 6. 3 to 6, and that's how you actually write the elements from 1 to something. So we need 3 to 6, so we just give double dot, and this will do the union of this previous L, which is now -3 to -3 to 4, 5, 8, 9, and then we do union with this one of 3 to 6 list, and that will be this thing. Perfect. Now similarly, we can also do intersection, and let's say we have L, and then in same intersection from 3 to 6, and that would be only 5 and 4. Perfect. You can also do the difference, and in the difference one, the difference can also be computed with the difference command, and that would be something like that. And but like these will only work if you define L as a set. Okay, perfect. Now we will talk about the set operations. Set operations. Okay. Sorry, those were the set operations. Now we will talk about the list operations. Right. Now GAPE contains powerful list operations that often can be used to implement simple programming tasks in a single line. The typical format for these operations is to give as arguments a list L and a function that is to be applied on the entries. Okay. Now these functions often are given in the shorthand form, like x tends to the function applied on x. Okay. Now let's say we can do something like this. So let's call our list, and we have elements in the list, or we have a range of elements from 1 to 10, and we want to do x. Now this x will take all of these values from 1 to 10, and if we write a function, so the function at this time is this expression x square, and now the elements of these list will be that it will be the square of every element from 1 to 10. Okay, similarly we can take a filtered list which takes elements from, let's take elements from 1 to 10, and the function is prime. Now this will tell us the prime numbers from 1 to, which comes in between 1 to 10, from 1 to 10. Okay. Yeah, the spelling for the filtered is wrong. Filtered. Okay. So this is how it works. You can also bring the number of elements. You can also use the number command to find out how many elements are there in the list which follow this property. Okay, and that will give us that there are four primes between 1 and 10. Okay, similarly you can just increase the number, let's say 100, that is just 25. You can increase the more number, and let's say just give it a square, and you can say that in 10,000 there are, from 1 to 10,000 there are 1229 prime numbers. Okay, now note that in the first example where we squared every number is such an inline function, right? So we can also define an inline function like this. Okay, this is function x. Now you can say print last. Okay, that will give you the function. It will give you the function, right? Perfect. Now the function first, let's say function first return the first element of L for which function returns true. So I'm gonna write few things here, you can understand those. So this is the function first, where we put list, and then the function returns the first element of L for which the function is true, right? Similarly, for all, using the function returns, if function returns true for all the entries of L, so for all is a function in which if we put a list and a function, it will return true if the function returns true for all the entries of L. Okay, and let me and then if we take the function for any, for any, it will take a list and a function, and it will return the function is true for at least one entry of L, right? And then we have a function which is collected L. Okay, so if for that, the collected L returns as statistics of the elements of L in the form of a list with entries, object slash count, how many number of elements of those. So if that object exists in a list, how many number of times? Okay, there is this function sum L, which actually add all the elements of the list. Okay, I just want to do one thing. Oh, perfect. And then I want to say something that there is this function, the variant sum of the sum, which says that the variant sum, which takes a list and a function, sums over the result of the function, which we have put there and applied to the entries of L. Okay. Now there is also another function which is product L, takes the product of entries of L. Okay. There is this function also. Right? Product L takes the product of the entries of L. Similarly, again, the product of L and the function, if we put applies the function to the entries of L first. Okay, so let's try all of these functions to the different lists. Right, so the function we said first will return the first element of L, which is true for this function. So it will return the first prime between 1000 to 2000. Okay, and that is 1009. Perfect. Now, remember for all function returns the value true if it is true for all the returns the function true for all the entries of L. Okay, so numbers between 1 to 10 are not all primes, so that's why it's false. Now, function collected from the list which is between 1 to 100 is prime returns a statistics of the elements of L in the form of a list with entries slash objects. Okay, that means there are 25 numbers which are prime between 1 and 100, and there are 75 numbers which are not prime. You can check by just considering that this will list all of them. Okay, but like you can just say the number of a list. Okay, so that means there are 25 prime numbers inside it, and then 75 for non-prime numbers, non-prime. Okay, perfect. Now the function sum takes the elements actually, and then add them. The sum from 1 to 10 is equal to 55. Now, let's take the sum from 1 to 10, but apply the function x square to them. That will be what? Like it will square the function and then add them. Or you can say over here, the sum which takes the list and the function sums over the result of the function. Okay, so it will square all of the numbers and then add them. That would be 385. Perfect. Now we can combine these list operations allows for the implementation of small programs. For example, the following commands calculate the first 13 Mersenne numbers and test which of these are prime. So let's say we have a list which contains which is the list from which has numbers from 1 to 13, and they go like 2 power x minus 1. It's better to write the power in the small brackets. Yeah, there should be a closed one. Okay, perfect. So what have you done? So what we have done here is that we have numbers from 1 to 13. We send them is the power of 2. We have subtract 1 from them and then send them to as a power of 2. Okay. Now we have defined this as a list. Now we will filter this list with the condition that filter L is prime. This will take how many numbers are there, how many prime numbers are there in the list L. Okay, and then that is just 2. Right. Okay. Let's remove these. Then I have different answers. And this over here, and now why I'm getting this, because I'm just giving x as a power of 2 and I'm subtracting -1 from the answer. Right. And now if I take the filtered is prime, that would be the different answer. Perfect. But like the same 2 operations I can do in the one single command, and that can be that filtered. Instead of this L, what I can do, I will just write this code here, this piece of code here, and that would actually do the similar thing, right? Now here we determine as statistics of the digits of the sum from 1 to n I square for n is less than or equal to 100. So n is less than or equal to 100. And if we have to do that, then what can we do is that we need to define the function which is collected, and we define the list, and then which we need sum from n is less than or equal to 100. So it should be 1 to 100. Now n goes to function sum. We are adding the numbers. Then function sum takes numbers from 1 to n. Okay. And then I goes to I square. I square. And then we mod 10. We mod 10. Okay. Right. That is the result. So here we have determined a statistics of the last digits of the sum from 1 to n of I square for n is less than or equal to 100. For a more involved example, the following construct: find all the Primical numbers between 1 and 2000, those non-primes n such that b power n minus 1 is congruent to 1 mod n. So we are talking about something like this. Hope this operation works here. Yeah, we are talking about this something like this. There's b power n minus 1. Okay, and then and this we can do by using the filtered command for a list which is already filtered. Is already filtered for the numbers between 2 to 2000. Right? We send n to not is prime of n and n goes to for all filtered 2 from n minus 1 from 2 to n minus 1, where b goes to GCD of b comma n is 1, where we send b to b power n minus 1 mod n equals to 1. Okay, that gives me the numbers which are those non-primes n such that b power n minus 1 is congruent to 1 mod n for all b less than n, given that GCD of b and n is 1. Those are 561, 1105, 1729. So that's how we do something like that with the filtered list command. So you can do more and more functions inside gap by so you can use lists, you can use sets, and then inside those lists and sets you can do functions, you can use other defined functions, And all these will help you to get what you have to do in the case of abstract algebra or group theory. Now, we can also do some basic programming in GAP. So let's say basic programming in GAP. Okay. Now, GAP includes the basic control structure found in almost any other programming language. We have loops and conditional statements. The basic loop is a for loop. So the basic loop is a for loop. Typically, it will repeat some instructions as a variable. It iterates through all the members of a list. The instructions begin with the word do and end with the word od. Okay. To continue with the example above, suppose we wanted to look at the number of divisors of some Mersenne numbers. Let's do that using the loop for. So we write for I in the list 1 to 13 to print the number of divisors of 2 power I I 2 power I. Sorry about the font. I just realized that I can actually make it make it bigger. So power I, comma, -1 -1 is length divisor this is int of 2 power I -1 and okay. So this is what the number of divisors of 2 power 1 -1 is 1, 2 power 2 -1 is 2, 2 power 3 -1 is 2, 2 power 4 -1 is 4. So these are the number of, not the answers of 2 power 4 -1, but actually the number of divisors of this number. Okay. Okay, perfect. That's we can do. Now, in this case, the variable is I is iterating over the numbers from 1 to 13. Notice the print command and the line break /n are used to make the output more readable and to force the system to send the printed line to the screen. Okay. The conditional statement begins with if, followed by a boolean, the word then, and the set of instructions, and it is finished with fi. Okay. Now, if you want to use some conditional statement which begins with if, and then it's gonna do then after the if, and then it's gonna finish with fi. The instructions are executed if and only if the boolean evaluates to true. Additional conditions and instructions may be given with the elif command with further conditions and else with no further conditions commands. For example, one can move input to the next line without evaluating by pressing shift plus enter. So that is, let's define a function which will give us the perfect number. So let's define a function which will give us a perfect number. That is function which takes some n, and we call it, now we take local sigma. What is sigma? Sigma is nothing but sum of devices, and int is integer. Now if the sigma is greater than 2 product of multiple of 2, then we do print n, n, which is abundant, okay, if sigma is 2 multiple of 2, then print n, it will be not the same one, but it is perfect. Right? Else, which will end the loop, which is the last condition, else print n is efficient, okay, fi and now fi will end the if command and will end the definition of the function, defining the function, okay, and that is the function. Now if you call the function perfect number, that's the name of the function, and you put the number 6 inside it, it will give you the answer for that, whether 6 is a perfect number or not. So indeed it is a perfect number. Now note that the function sum and divisors int are built in to gap. As a general tip, if the conditional statement is going to be applied to several pieces of data, it is usually easier to write a function that returns a Boolean value and then use the filtered command rather than combining loops and conditionals. Okay, perfect. Now, we can do so many other things in gap, like files, we can call files, we can save functions, and we can do more things. You can define polynomials, blah, blah, blah. Okay, so let's talk about few other things in the next lecture.